Today we are continuing our work with functions and beginning our work with function notation. So we have previously covered some basics in terms of working and identifying functions, and so we're going to solidify some of these ideas with our notes and then also begin how this relates to function notation. So it says a function is a relation between a given set of elements such that for each element in the domain there exists exactly one element in the range. So remember that when we're talking about the domain and our range, that we have to know which values we're referring to. And so remember that our domain are our x values and our range are the y values. So when we're looking for this relationship to determine if it's a function or not, we have to make sure that we are looking for the right pieces of the relation. So there are a couple of different representations we've seen with functions, and so we're going to go through each one of those and apply this rule of function to each one of them to see how you would tell if a relation is a function or not. So the first part, it says, given x and y values, if the x values repeat, then it is not a function. So we're focusing on our x values because that is our domain. And we're also making sure that if they repeat, then it's not a function. So if we are given our domain here of -2, 0, 3, and 4, we are looking to see if our domain matches with more than one value of the range. So with the mapping, we are looking to see if a value of the domain has two arrows going to different values in the range. So -2 is paired only with -3, 0 is paired only with 6, 3 is paired only with 6, and 4 is paired only with 9. So it doesn't matter that the range value of 6 is used twice. That doesn't make a difference. It's looking that the domain is matched with only one value in the range. So this would in fact then be a function. If we are given a table of values where we have our x and y values, so we have x is -4, x is -1, 0, and 3. So we can see that all of our x values are different. And so then this would mean that this is a function. So even though all of the range values are the same, that doesn't matter. So we're looking at our domain values. So this would be a function. Another mapping, so -4 is paired with -1, -2 is paired only with 4, 0 is paired only with -1, 2 is paired only with 1, and 4 is paired only with 4. So each one of the domain values only goes to one value of the range, so this would be a function. In looking at a set of ordered pairs, so we have our x and our y values given to us, and so since we're focusing on our domain values, so we have a domain of 6, a domain of 4, a domain of 6, and a domain of 5. So we can see that there are two 6's, and so we need to double check and make sure. So 6 is paired with 5 here, and 6 is paired with 4 in this ordered pair. So it can't be matched up with a different range value, so then this would mean that this is not a function. So if we are given x and y values, these are some ways that you can determine if a relation is a function. So now we're going to apply a vertical line test if we are given a graph. So if a vertical line intersects a graph more than once, then it is not a function. So one thing I want to stress to you is that it's really important that you use more than one vertical line, because you will encounter some graphs that if you place the vertical line in one particular place, that it's going to look like a function, but if you keep testing that graph with a vertical line, that it ends up not being a function. So make sure that you use more than one vertical line. And you can use the edge of a piece of paper or your pencil, something to determine if the graph is a function. So on my graph, I have a parabola here, and so I'm just going to draw some vertical lines and see if, and it doesn't matter where they are, I'm just going to draw a few of them and make sure that my graph only hits that vertical line in one place. So I'm going to draw a few vertical lines, and then I'm going to go back and look. So I have drawn some lines on my graph, and so now I'm going to go back through and see if in fact this is a function. So with this first vertical line, it hits that parabola at that one place, and so that's what we're looking for. It hits the graph once. So with this second vertical line, it hits the graph in one place. The third vertical line, it hits the graph one place. The next vertical line, it hits the graph one place. And I can continue this and see that each time I drew a vertical line, that it intersected this graph only one time. So this would mean that this is a function. So let's look at the next graph. So I'm going to draw some vertical lines. Oops. Not a very good vertical line. Let me straighten that out really quick. There we go. And I'm going to draw my lines, and then I'm going to go back through and look at them. And remember, it doesn't matter, how many necessarily or where your lines are, so you can see that mine are spaced out differently, and that's okay. So we're just trying to get some information from our graph. So on this graph, I can see that it intersects, that vertical line intersects the graph one place here, and it also intersects it there. So I intersect this graph two places. Same thing with this line. So remember that our goal to see if it's a function with a vertical line is that it can only intersect the graph one place. And each of these vertical lines intersects the graph in more than one place. And it doesn't matter that all of them, all that matters is that one of them intersects the graph in more than one place. So from the first line, I could tell that this was not a function. So these were continuous graphs, and so now we're looking at a discrete graph. So remember that the discrete graphs are points that aren't connected, so they're individual pieces of data. And so you do need to make sure that you go through the points on those. So I'm going to draw a vertical line as best I can through each one of those points, and then I'm going to go back through and see if they pass the vertical line test or not. So I have all of my vertical lines, and so now I'm going to go back through and check each one of my vertical lines. So my vertical line here only hit that one point. This vertical line intersected twice. So just from that alone, all I need is one line, and it intersected that vertical line two times, so this means that this is also not a function. So it doesn't matter that the other points only intersected once. If one area of your graph intersects the vertical line in more than one place, then you can tell that it's not a function. So last one. So draw a series of vertical lines. And then we'll test these and see how they turn out. So I'm going to verify my vertical line on the line that's already there. And so I can see that each vertical line only intersects the graph in one place, so this is a function. So when we are working with our function notation, and as we have talked about a lot of terminology and dealing with functions and relations, there are some words that I want you to make sure that you're familiar with. So on your note sheet, we are going to identify how we can label our x values. So we can refer to it as our x value, our input, our domain, and our independent variable. And when we're talking about our y values, we have y, we have f of x, and it's really important that you write how you read this, and you read this as f of x. Our output value, our range, and our dependent variable. So as we continue working with functions, we think of functions as being a machine. And so what we input, there's some sort of function going on inside the machine, and it's going to output something else. And so we can see in these equations that we have y equals 3x, where our x value is our input in the blue, and our output is our y value, which is red. And we can write this same equation of y equals 3x as f of x equals 3x. So we can replace y with f of x, which is part of this function notation that you're going to be seeing. So function notation, it says that equations that are functions can be written in a form called function notation. So it has to be a function for it to be able to be written this way. So if we have the equation y equals 3x minus 8, so we have that as an equation, we can write that in function notation as f of x equals 3x minus 8. So we're going to work with function notation in terms of some values. So if we have for f of x equals 3x minus 4, we want to find f of 4. And so our first step is going to be to plug in our value of 4 in for x. And so you've seen these types of things with equations, and so now we're going to apply this to functions. So we would write f of 4. So all we're doing is we're plugging our value, f of 4, in for our x. So f of 4 equals 3, and so we're going to replace each value of x to be 4. So 3 times 4 minus 4. So then f of 4, 3 times 4 is 12. Minus 4. So f of 4 is 8. So if we were to write this as an ordered pair, our x value was 4, and our y value, our f of x value in this case, is our output, is 8. So let's try another one. So if we have f of negative 5, so we're plugging f of negative 5. So negative 5 is going to go in for our value of x. So 3 times negative 5 minus 4. So f of negative 5 is 3 times negative 5 is negative 15 minus 4. So f of negative 5 is negative 15 minus 4 is negative 19. So as an ordered pair, we would have negative 5 as our x value and negative 19. So our input and our output. So let's try f of 0. So f of 0 equals 3 times 0 minus 4. 3 times 0 is 0 minus 4. So f of 0 is negative 4. So as an ordered pair, our x value or input is 0, and our y value or our f of x value or output is negative 4. So let's look at another one. So in this case, we had our function of f of x, and so you're going to see these values change, like g of x, h of x. It really doesn't matter, and it doesn't have to be f of x, so that's why I put one on here so you could see it's the same idea and you use it the same way, but that variable out in front may change. So it still is considered a function, and so now we don't read this f of x, we read this g of x. So for g of x equals x squared plus 1, so for each value of our x that we plug in, we're going to find our output value. So for g of negative 1, so our x value in this case, we're going to plug in to be negative 1. So we would have negative 1 squared plus 1. So g of negative 1. Well, negative 1 squared is the same as negative 1 times negative 1, which would give us a positive 1. So we would have 1 plus 1. So g of negative 1 is 2. So as an ordered pair, our input is negative 1 and our output is 2. So working with g of 3, so we would have 3 squared plus 1. So g of 3 equals 3 squared is 9 plus 1. So g of 3 equals 10. So our input value is 3 and our output value is 10. All right, last one, g of negative 4. So g of negative 4 equals negative 4 squared. Make sure that you do put parentheses around your negative 4. If you don't put parentheses around your negative 4, it means something different. So make sure you put parentheses around that value. So g of negative 4 equals negative 4 squared is the same as negative 4 times negative 4, which gives you a positive 16 plus 1. So g of negative 4 is 16 plus 1 is 17. So our input was negative 4 and our output was 17. So let's look at a situation where function notation can be used. So it says you are buying orange juice for $4.50 per container and have a gift card worth $7. The function f of x equals 4 and 50 x minus 7 represents your total cost, f of x, if you buy x containers of orange juice and use the gift card. How much do you pay to buy 4 containers of orange juice? So in this case, it gives us our function. So our function in this case was f of x equals 450 x minus 7. So this is our output is going to be our total cost. So our output is our total cost. Let me rewrite that. And so then our input is the number of containers. And so we're going to input the value of 4. So all we are trying to do is find f of 4. And we're going to plug that value into our function. So 450 times 4 minus 7. So when we evaluate this, so 450 times 4, so f of 4, 450 times 4 is 18, minus 7, so f of 4 is 11. So our output value is 11, so that means that we would spend $11 on 4 containers of orange juice. So now you have an assignment that will be practicing this function notation as well as reviewing functions and determining if it's a function from a graph and from x and y values.